Good morning, everyone. It's a great pleasure to welcome you all to this Kjeltec webinar, which is the first of a series of 4. My name is Charlotte Israelsen, and I'm the Global Key Account and Market Manager responsible for the Global Laboratory segment. As a laboratory, it is critical to maintain analytic instruments in order to ensure accuracy and decrease downtime. Our main focus on our webinars will therefore be describing theory, basic maintenance, and troubleshooting on our automated chemical analysis instruments. Please find more information about our coming webinars on this page. Today's topic will be about the Kjeltec and the Digestor. But before starting the webinar, I would like to highlight some housekeeping items. If you cannot hear the introduction at this time, please check the volume of your computers. All lines must be muted during the presentations. Use the question function during the webinar to ask your questions. The line will be open again after the presentation for a Q&A session. All questions will be compliant and answered. Our main speaker today will be Carrie Sun, who is our product manager, Maria Bigman, who is our market specialist, Marcy Russell, who is our local sales manager, and Bradley Bushman, who is our local field service manager. The agenda for today will be, first of all, a very short introduction of FOSS. Then Carrie Sun will take over and talk about product theory of the Kjeltec and the basic maintenance of Digestor and Kjeltec. Maria Wickman will talk about troubleshooting for protein analysis. Bradley Bushman will give you an introduction to our service organization, and Marcy Russell will talk about the sales organization before we hand over to a Q&A session. FOSS was founded by a Danish man called Niels Foss in 1956. Niels Foss has identified the need for a portable moisture analyzer. It had to be fast, easy to use, and dedicated, and therefore the Sierra tester was the first of FOSS innovation instruments. Maintaining innovative technology to the demand of particular industries has been the foundation of FOSS ever since. Our mission is to contribute to sustainable use of our planet's agricultural resources and thus the nutrition and health of the people of the world. We provide analytics beyond measure and add value to our customers by providing quality and optimizing food and agriculture production. FOSS is global present, and you can always reach out to your local service manager or your local sales manager. We have more than 300 service engineers and application specialists who is operating from more than 28 countries. Their main focus will be to be fast on site to avoid any breakdown for your FOSS instruments. Once again, thank you so much for participating today. I hope you will enjoy this training session and looking forward to seeing you all back next week when we will talk about our SOX-TEC. I'll now hand over to Carrie Sun, who will give you an introduction to the product theory. Thank you so much.
Okay, thanks, Charlotte. I will just start this presentation about the Kjeldahl nitrogen information and the Kjeltec introduction. I'm Carrie Sun, I'm product manager in FOSS. It's my pleasure to be here to introduce you the theory and also the instrument. And later, I'll just give you some introduction for the maintenance. So as you know, the Kjeltec you used is from FOSS. It's used to determine the protein. And here is a resource which contains protein, and you can analyze dairy, you can analyze the feed, forage, and some even the seafood. And the method here used is called a Kjeldahl. So actually, the method is used to determine the nitrogen. And from nitrogen, you can measure the protein. And if you look into nitrogen format, actually, it's quite a lot format for the nitrogen. And only the first 4, they are called the Kjeldahl nitrogen. They are the nitrogen format can be analyzed according to the Kjeldahl method. And other 2, nitrate and the nitrate, they are other part inorganic. They cannot determine by the Kjeldahl. So this is all the nitrogen here called the total nitrogen. And why the protein can be analyzed by the Kjeldahl method? we should look into this structure. So from the structure, you can see here, the nitrogen is like the chain, and which is constituted by the amino acid. So amino acid is basic unit. And amino acid has a nitrogen molecule inside. So each amino acid has a nitrogen molecule. So it was one nitrogen in each basic unit. If you break this organic protein chain, you can get this nitrogen. And the way in the Kjeldahl method is break this nitrogen into inorganic ammonium ions. Then you determine it based on the Kjeldahl method. And the Kjeldahl method actually, it contains 4 steps. I give you a very clear picture with what they are. So there's sample preparation steps, digestion steps, distillation steps, titration, and the calculation steps. And as FOSS, we provide all the instruments in 4 steps, and we give you the solutions. So for the whole thing, we provide total solution. I will go to each steps and just describe how we can determine the nitrogen in the Kjeldahl method. So first is the sample preparation. The sample preparation is we want to get the homogenized particles, which can give you very representative of the bulk, and then it can be just analyzed, or which can be analyzed or prepared in the further steps of the digestion. And usually where we have the meals which can be used for the preparation, and in FOSS we provide different types of meals. Here you can see a meal that was KN 900 and 295 KNIFE-TEC. This is KNIFE-TEC, which used to handle the high-fat, high-moisture samples. And also we have the other meals like in KNIFE-TEC, which has CYCLETEC, and which used to have very homogenized particle size distribution. Then in the steps, in the preparation steps, also you can try to dry the samples, which you can get the nitrogen result based on the dry metal. And the other step in the preparation is the weighing the steps. So weighing is also important because for the Kjeldahl method, there's like the range which you can measure for the nitrogen content based on method. If you are weighing too much for the samples, it will be exceeded the limit, and then the method is not applied, and you may get to the result which is wrong. Also, if you are weighing too little, and then if the content is low, then you also have problems. So it will just lower the limit, and the result can be not measured. So the steps, the sample preparation steps, including the preparation, the grinding, also the weighing. And then the second step is the digestion. The digestion is like here, as mentioned, that we have the steps which you can change. I just gave you the laser point, which you have this carbon-nitrogen bond, which you break the bond and get this organic nitrogen into inorganic ammonium ions. And in the steps, you have the catalyst and the sulfuric acid. These are to use one sulfuric acid is used to destruct this bond, and the catalyst is used to speed up the reaction. And this is very traditional setup for the Kjeldahl method. You have this Kjeldahl flasker. It was used. There's the heat resource which heats up the temperature. But in FOSS solution, we turn this setup into digestion tubes. So this is like bench handling, and this is in the block. This is called block digestion, and it's the same principle. We have organic samples in the digestion tube, and the sulfuric acid is boiled. And at the high temperature, then with the Kjeltec, which is the combination of the salt and the catalyst, which will break the nitrogen carbon bond to the ammonia ions. So we have this method in the block digestion, which is more efficient, which can handle up to 20 samples in 215 digestion tube. And the commercial product we are providing here is a Kjeltec. It contains 2 composites. One is salt. Salt used to increase the temperature for the boiling temperature for sulfuric acid. Usually boiling temperature of the pure sulfuric acid is 338 degrees Celsius. But with the salt added, you can increase the temperature higher up to 385 degrees. And there's some information from a study, actually every 10 degrees increase, which can have the reaction speed doubled. So here we increase the temperature like close to 6 degrees, it's quite much the increase for the speed. So in the traditional method, you have the reaction like several hours for 3, 4 hours, 5 hours, but in our bulk digestion, you can get the reaction done in 1 hour for the normal sample types. And the other thing is the catalyst. Catalyst is also the thing that you speed up reaction, and there are quite a lot of catalyst types used for the reaction. And the most common used one is Cooper right now. And also in old days, people use mercury, but right now the mercury has been forbidden because this is toxic. It's also not environment friendly. And right now the most used type is Cooper. The Cooper, the purpose like it will reduce the energy of the reaction, then the reaction for the breakdown the carbon-nitrogen bond. So the nitrogen carbon-nitrogen bond is the reaction energy is reduced, the active energy is reduced, and the reaction can be speed up. And this is a normal setup for the digestion procedures. So we have the sample weight is usually 1 gram, but this is usually depend on the nitrogen content. If you have a high nitrogen content, like a whey protein concentration, you can reduce it to like 0.3 gram. If you have very low nitrogen content, sometimes probably starch, you have to increase it to like 2-3 grams. So this depends on the sample type. And the other thing is also catalyst, and normal recommendation from FOSS is 2 Kjeltabs, Cooper 3.5. So this is the Kjeltabs which contains 3.5 gram salt, that is potassium sulfite, also 0.4 gram Cooper. The other thing also, it depends on the method that you are following, because usually the standard were very clear, clarified which catalyst has been used. So you can look into the standard and determine which types of catalyst has been used in this application. And the normal sulfur gas, the volume is 12 milliliter, but sometimes if you see the high fat and the high carbohydrate content, you have to increase the volume to like 15, sometimes even 20 milliliter. And the temperature setting is 420 degrees. This is a normal setting. And in our digester, the maximum temperature setting is 440, because we see if the temperature is higher than 440, and there's a risk, actually not risk, actually this is a problem that the nitrogen and the ammonia, actually after reaction, the carbon nitrogen bond is break, and then it turns to the ammonia ions. And this ammonia ions at the 440 degrees, it turns to the nitrogen gas. So there'll be a nitrogen loss in the procedure. So that's why we have to control the temperature below 440, and we set the 420 for digestion. And the normal time setting is 60 minutes, but it also depends on sample type or the amino acid type, the chains. And usually if you have the diary, then you may need a longer time for breaking the carbon nitrogen bond. So sometimes for the diary sample, like liquid milk or some cheese, you even need a longer time, like 2 hours. So we have very clear application notes which describe the method that you can refer to and determine the time for the digestion. And there's some information that give you what kind of why we have to set a different digestion time. And usually there are two type samples, and like the sample type 1. So for this one, it's like the boiling period is not necessary, because you see for the reaction after 30 minutes, the recovery for the nitrogen is also like constant. You don't need a boiling time. So this is like 60 minutes is enough. Even you can short it to the 45 minutes. And for the other types, like type A, you need a longer time, because you see even after 60 minutes, still here you can see a trend for the increase of the nitrogen content. So this is like the nitrogen is not completely recovered in the process. You need a boiling period. And this can be referred to sample type like diary. And some other types of which has high protein content or high fat content, it requires a longer time to break out the bond in the sample types. So we have some information in the application notes which give you a detail of how long is for the digestion on each sample types. And also when you handle the liquid sample also very typical in the method, like the beer, like the liquid milk, and the ramping is a procedure, because when you handle the wastewater, when you just have digestion quite a lot of the sample, a liquid sample which contains much water, you need the ramping procedure which evaporates water first. Otherwise, you will see like very strong digestion in the tube. There's pumping, and the liquid is out. So the recommendation is like you use a ramping procedure to have this the water is evaporated. The other thing is boiling rod can be used to control the digestion. But in FOSS system, we don't recommend you use the boiling bead or the boiling stone, because in our Kjeltec there's automatic draining. If you use the bead and the stone and you drain it automatically, this stone or bead can block the draining flows. So there's a risk of high pressure in the system. So there'll be error message. So we still recommend you use a boiling rod to avoid this strong reaction, the bumping inside the digestion tube. And then the third step for the system is distillation. And the distillation, this is the very traditional setup. You have this the heater source, which we're just at the presence of the sodium hydroxide. This ammonium ions is turned to ammonium, then it's separating the condenser and trapped by the boric acid. Then you have the ammonium ions again. So this ammonia is separated from the digestion mixture solution. And you have to determine the digestion steps. That is the next steps. And this is what's happening in our digestion system. So the water is added for the dilution because we want to avoid a very strong reaction if only sodium hydroxide is added. Then sodium hydroxide is added for the reaction, and the steam is like added to just take the ammonia out and trapped by the received solution. The normal procedure here in our FOSS system, this is a distillation steps. We have 80 milliliter water, and then there's sodium hydroxide for release ammonia. So we add 50 to 60 milliliter, 40% weight of volume, the sodium hydroxide, and the distillation time is 3 to 5 minutes. I will explain why it has to be 3 to 5 minutes. Then the ammonia is trapped in the boric acid solution. And here's some explanation why we need 3 to 5 minutes. And there's some figures which were based on the study. And because usually we say the best range for the analysis is like 30 milligram nitrogen, absolute nitrogen in the samples, or to like 140 milligram. And if we do the study for the 30 milligram absolute nitrogen and 200 milligram absolute nitrogen, you can see for the 30 milligram, this is the red curve. And you can see about 3.5 minutes, the nitrogen is recovered completely. But like 200 milligram absolute nitrogen, it takes longer time. It's up to like 6.5 minutes. Then you get the complete recovery for the nitrogen. And because we say the range for our system like 30 milligram to 140 milligram, that's the optimized range. So we usually say 3 to 5 minutes, you can get all the nitrogen recovery in the system. And also in our Kjeltec system, it's different from other competitors. We have this online titration. So the titration is just at the same time with distillation. So it's online titration. So when the distillates come in, the burette starts to work, give the titrate, and there's a system, the LED just emits the light, and the detector just to measure the color change if it reaches the endpoint. And for the distillation, also for us, we have 2 different procedures for the steam addition. There's one called a delay. This is like we will have the steam added later, so we were just ensure that there's a mixture of the alkaline and the acid first. But this can be some problems because alkaline usually is heavy, so when the alkaline is added after dilution, alkaline will just sink. Then there's some reaction with alkaline and this concentrated acid. This is acid from the after digestion. So can be some strong reaction at first. Then can be some bumping inside digestion tube. But if we just develop another sequence. It's called SAFE. It's a steam addition for equipment. So it's like, there's dilution, but after dilution, and we have the distillation first. So this steam is added to mix the water and the salt. Then the concentration for this digestion mixture is diluted. Then after you add some strong alkaline, the reaction can be well controlled. It's not that strong, so there will be not very strong reaction in the digestion tube, which can avoid some problem. Also, you can try to use some special application that need a very concentrated acid for the distillation. Then with this steam procedures, it's like a dilution is first, then it's just dilute the strong acid inside the digestion tube, which will be safe for the operator. And the last step for the Kjeldahl method is the titration. And the titration, of course, this is a determination way of the compound in the sample by the controlled addition of the reagent of no concentration. So we have all the ammonia is trapped. This is the ammonia ions, and then we use no concentration hydrochloric acid or sulfuric acid to determine the content of the ammonia. And usually, because this is a colorimetric method, so it's also based on actually the principle is in this received solution that there's an indicator which shows the color change based on the pH value. So, and there's an equivalence point that when there's some nitrates added, there's like a steep change from the low pH to the high, or from the high to the low. And the principle, like here, is usually this is acid-base equivalence change at pH 7. But for this, for our system, for the endpoint determination for the ammonia, and the equivalence pH value is about 4.3. And at this point, there's a very significant color change for the system, because in the system, we use methyl red and bromocresol green for determination for this mixture indicator, and the color change will be like from the green from green to the red again. So this is the initial color for your preparation with boric acid and the indicator, because this is acidic. So when you after preparation add this both combination mixture of the boric with the indicator, you will get this initial color. It's like the wine. It's like a little bit red, the dark red. And when this received solution trap the ammonia, it will get green. And after you start the titration, it will just get to it's green, and then it will get to gray a little bit gradually. And this is like intermediate time. When this is like very close to the equivalence point, when you add some more like several drops, it will get to the end point. It will be like the pinkish, light pink again. So that will be the end point. And in each steps, you have to run a blank. Blank means there's no sample inside. It's just the sulfuric acid with some digestion with some Kjeltec. So you will get a value for the volume of the titration. And also you run samples, you will get the volume. And based on this, you can get the nitrogen content based on this formula. So you get the volume, and the times the N is a normality for the titrate, and the times the molecular weight for the nitrogen, and divided by the sample weight. So you will get the nitrogen content in the sample. And if you want to determine the protein content, there's a formula also. You just times the factor. The factor is used is very typical in all the literatures, and you can find this factor. And for the crude protein, the factor is 6.25. So you just use nitrogen content times 6.25, or gets the number. And like for others, so this is general, or like the processed food or mixtures. And if you are just want to measure some grains, they have different factors because they have different ammonia acid, which is included, very specific. So for the wheat, it's 5.7. If it's a dairy, that is 6.38. So you can also look into literatures, get the required the factors for the determination. We are providing a range. So before that was more like principles, and of course we decide the product based on the principles. And right now we have a range of the digester and the Kjeltec, which we are just selling. Right now, this is the portfolio we are selling for the digester. We have 8 positions, 20 positions. We cover the manual version, also the automatic version. And also we providing the exhaust, which used to just aspirate the fumes, because you have to work into the fumes to get the acid that has reflux, which can ensure the digestion is complete in the digestion block. And also we provide a scrubber, which is a solution which can just treat the fumes, which is the waste fumes. Then you don't need to just leave the fumes inside the fume hood, which will damage the fume hood as well. So there's like the treatment the units which can handle the like SO2 gas from the fume waste. And the other thing, actually, this digester, for the automatic version, we are providing there's the building applications. This is also application note which has been preset in the digester software. You can have up to 127 applications, and this application are all based on the reference method. You can just pick up the one and run the application, select the application and then run it. And also the software is very good for the traceabilities, and we have all the log data, the time, temperature, application, operator, batch informations, building. So you can use the PC software, which can be connected with digester to read also the log files and have this for traceabilities. And for the Kjeltec solutions, right now we are providing 3 Kjeltecs in our portfolio. They are from like the basic distillation unit to the complete automatic distillation unit, and to the analyzer. So analyzer gives you this online titration. It gives the result at the same time when distillation happens. So it's compared with competitors, it gives quite short time for the whole analysis. So usually you can get the result in 5 minutes for each sample after digestion. And for the customers has a high throughput. Also, we are providing the auto samplers. So this is complete relief, the resource relief for the operators. So it's just after digestion, you just load the whole batch of the racks. Then the 20 positions, it can handle one batch, 20 samples in once. And for the 6 sampler, it can handle 60 samples at once. So this is a complete save the human resource in the lab. And the other thing also, we are providing a software which is called Campus. This is data management software, and this software can be used as a tool for sample registration. Also, it can be used to track the data, get the result back in the PC software, getting the report, and have the LIMS export and import. For the registration, it can have the LIMS import. So you can get it can be connected to your LIMS system to get the sample weight if you are doing the weighing with balance, and the balance gives the result, export the weight to the LIMS system. Then the Campus software can collect the LIMS the weight into the system and create a batch. And after that, it can generate the LIMS report, LIMS XML file to the specified server address. Then you can get the LIMS export. And in the system, you can have all the program settings, the user settings. It's a faster registration procedure, and the complete system follows the GLP routines. So this is some basic introduction for the instrument as well. And we are going to the next part is about the maintenance. I will start with digester, then we go through the Kjeltec. The first is digester maintenance. And I will give you some videos which you can go through. The first will be the digester tubes, and then will be exhaust, how to clean the exhaust, and the last thing is how to just maintain the scrubber. I will start with digestion tube.
Hello, my name is Jacob. I'm a product specialist for the lab segment at FOSS. And today I'm going to show you how to use a retainer plate for cleaning of the tubes for the Kjeltec system. And this is the rack for 20 samples, and here we have a retainer plate, and you can open by taking out this metal part here and then put it on top of the racks like this, and then you pull up the rack and close the retainer plate. Now the retainer plate is in place on top of the tubes, and you can handle it like this, so you can empty it or clean it, whatever you like. So now I'm going to show you how to clean the exhaust from the digester, and I've taken out the exhaust from the digester here and put it in a plastic beaker, and within this there's hot water. And for effective cleaning of this and removal of most of the acids, you can use this system. It's a water aspiration pump. You have a flask here for trapping of the liquid, and you need to connect the exhaust by doing like this, and then simply just turn on the water at the high speed. And then all of these 20 manifolds will be cleaned, and the waste will be collected in this flask here. So that's an effective way of removing most of the acid. When you've done that, you can turn it down. You can disconnect this one here. And then if any leftovers are not removed, you can use this small flask cleaner and take out the rest here. And of course you can do that for each manifold and then do another cleaning. When you're done cleaning, you can take out the exhaust and let it dry until next analysis. Hello, my name is Jacob. I'm a product specialist for the lab segment at FOSS. Today we have this scrubber unit, and this is how it looks when you prepare it for use for sucking the acid fumes from the digester here. So in this beaker here we have the sodium hydroxide solution from 10 to 15%, and within this beaker we have an indicator. It's called bromomethyl blue, and it's blue now because it's alkaline, and this is the solution when it's neutral. And the level for the liquid for the water here is this, except for when you have much moisture or water in the samples, you need to have 1/3 of water here. So that's how it looks when you start the digestion. For ensuring the correct vacuum for the scrubber unit, you can actually adjust the disc, the two discs that is within this two flask. So you can take it out here and lift it up, and then you can turn this up or down, and it will then at the correct position have a good vacuum when you put it again. So this is how it looks when the alkaline has become acidic and the indicator has changed to yellow color. And now it's time for emptying the waste and exchange fluid. You can do this by using this water aspiration pump here, and you take out this sealing here, and you turn on the water aspiration pump. Then you so now the liquid will be drained by using this water aspiration pump, and it goes through the same for the acid solution over here. So that's how it works. When you have taken out all the liquid and you need to refill it again to this level here, and for both solutions, the alkaline and the water, and if you have a lot of moisture or water in the samples, then you need to have approximately at this level for the water.
Okay, here I just continue the Kjeltec part for maintenance. Actually, you can find this all information from a user manual. Actually, we divided the maintenance into daily, weekly, monthly, and additional, and the yearly preventative maintenance. And here's some information that you can change. You can find it in the user manual, and I will just go through from daily to the additional. The first is daily. And we have some very important procedures like steam cleaning. So steam cleaning is like after you finish all the analysis, you have to use a steam to clean the flow system. So to ensure there's no like ammonia residues inside the system, so just to clean the system to make sure it's maintained. And the other thing is also you have to clean the drip train, the tube spool, and the safety door. So this is something that you have to clean daily after running the analysis, because there's some spillage on the tubes like safety door. And the other thing, you have to check the digestion vessel. because the titration vessel can have some like indicators or some boric acid residues there, so which can have some effect on the LED detection. So that's the reason you have to check it. I will just give you some videos on each part. So the first is steam cleaning. Now this is the first step. We will add water to the digestion tube. We will choose 150 milliliter. You can control it by press a button. Then you add, so there will be water dosed in the digestion tube. Yeah, then we move to next step. You can choose add steam. Press that. Then the steam will be added now. Next, you can drain the water in the digestion tube to finish this steam cleaning. And this is the next part. This is the clean drip train, tube support, and the safety door. And we will have a look at the video. We start right now for the drip train cleaning and also tube support and safety door. So first is open the safety door and take out the digestion tube. Here you can lift up a fixer and then take out drip train. Then there's a tube support. Then there's a drip train you can take out here. So we can place this too in the basin for the cleaning. Now we will just take out the safety door. So the way is that you lift up safety door a little bit and take out it from the chamber. Okay, it's the same way that you just wash the safety door with water and some neutral detergent, not the solvent, alkyl, ethanol or some other organic solvent. It's important that use a neutral detergent or just water. Then you can just dry the parts aside, or just use cloth to wipe them. Okay, now we just put back the safety door. There's a slot you can slide in. And lift a little bit up the safety door. Then you can put it in the right position. Check if it's in the place. Yeah. Then next you will take the drip tray back, insert. Then it's a tube support. And you have to put this small metal piece back to fix the tube support. Okay, so this is the way you have to do the cleaning of the safety door, drip train, and the tube support. Now we just continue the daily maintenance. This is part of the check the digestion vessel. As mentioned, at this neck position, it's very easy to get some receive solution, the indicator. So it's quite important you have this small brush just to clean the positions. Try to ensure there's no any just indicators here, because there's a detector. The LED is just emit, and through this neck and the deck in the back side, it will just measure the LED. If there's any indicator stick on the wall, it will affect results. So it's also be checked if it's clean for the digestion vessel neck. Then we have some weekly maintenance. So you have to check the safety features, check the reagent tank, also check the digestion tube, and also check some drip train in the auto-exemplar if you have auto-exemplar. The safety features like you have to try to open the door and in the analysis and to ensure if the analysis will be stopped. And also you can try to start analysis without the tube. This is to check the tube in position sensor, in place sensor is working. And also you have to start analysis without or turn off the cooling water. This is just to test the temperature sensor for the distillates is working properly. Because if the temperature sensor is not working, then it can give you some problems. When the cooling water is not on, then you will get the result which is not accurate because the distillate temperature is too high, which can cause this ammonia loss in the procedure. And also you have to check the exemplars, and you can open these two doors. One is the exemplar door, the other is the surface door. If you open these two doors in the analysis, if the instrument will stop. This is just also the other safety feature to ensure we provide the protection for the operator. And the other thing is check the digestion tube. It's like the tubes. You can check the rim if there are any chips, or if there's any scratch on some cracks or some fractures on the body of the digestion tube. Because if you have these chips at the rim, you may have some leakage in the distillation procedures. If you have some scratch or cracks, there become issues in the digestion or the distillation. The tube is broken, so that will be dangerous. So you have to check the digestion if they are in the good condition. And the other thing is monthly maintenance. You have to clean the alkaline pumps and the receive solution pump. They are almost the procedures. I will show a video. And also you have to clean the splash head. I will also have a video. The other thing is to check the tube adapter. Tube adapter is a well part. It will get very, very soft, very hard after use. You have to just ensure it's still soft. And if it's hard, you have to replace it. Otherwise, it will not have very good seal. So you have leakage in the distillation procedures. I will start with cleaning the splash head. So here's a video. Now we will start the cleaning of the splash head. First, we need to prepare citric acid and water. First is 25 milliliter water. Prepare 25 milliliter water. Then pour in the digestion tube. Then measure 25 milliliter citric acid. It will be the same, just add it, so there will be like 50% citric acid solution. Next step is load this tube into the Kjeltec. Now we load the tube, close the safety door, and add the steam. So it will take 5 to 10 minutes. Now after 5 minutes, you can just stop the steam and drain the tube. we use another tube to fill in 100 milliliter water and do the cleaning. So now it's a distillation cleaning with water. Okay, next part is about cleaning of the ALKALI pump. So it's almost the same procedure for the received solution pump. So you can just follow the procedure to clean both pumps. So this is the steps we just do cleaning the ALKALI pump. First step is take out the tube from the tank, place it in another like flasker or container, because we will have a step that we will just drain out the remaining ALKALI in the ALKALI pump. We move to the instrument side, and we will just use a manual mode to add ALKALI. So you can choose the volume to the maximum, like 150, and try to add. So now you see the dose pump is working. Now you see the pump is not adding more, but still working. So that means the tube inside is emptied. So now we can drain the ALKALI with empty function. Start draining. Next step is we needed to reflush the tube, so we can put the tube in a flasker that contains some warm water. So we put the tube in the flasker now. Then we use the adding ALKALI function to reflush the tube, the ALKALI pump. So first we still need to close the safety door. Adding the pump, you choose the maximum volume. You have to repeat it several times. Now you can see there's no reagent added because this tubing is still empty, and then now the water is coming. So you have to reduce it several times. This is reflushing the ALKALI pump to remove the crystal inside. So now you can empty the tube by adding by tube empty. Try to repeat this procedures several times. Now this is the part for also for the monthly maintenance. And the thing that you have to check the tube adapter, and so here you have to check if there's any scratch or the cracks on the rim, and also need to inspect the hardness, because if there are any issues with hardness or these cracks, then can cause problem due to the leaking. So you have to change it. And also customers may see if when you get the new samples, it's also get very hard. It's difficult to put on. You can try to put this adapter in the hot water. Just to soft it, then it will be simplify the fitting procedures. So this is some tips. And some other additional information here is also the information you can find in the user manual. There'll be some procedures for to clean the steam generator. but because we use deionized water or distilled water, so it's not that easy. The steam generator get some algae inside, so it's not that dirty. And also some procedures you have to clean the burette, and also there be the digestion vessel you have to clean. It's also the same procedure as described before. So this information is available in the use manual. And the other thing that is also all the service we are providing right now from FOSS, that is preventive maintenance. So it's a part that our service engineer will be on site, replace all the tubings, change all the well parts, and check the key components function, especially like safety function and other functions, like the pump, if the alkali pump or boric acid pump, if they are working properly. Then after some like the maintenance, the engineers will verify your instrument again to ensure the instrument is in good condition and performing correctly. So this is the extra service we are providing for the Kjeltec. And thank you for listening. And I will handle this now to Maria. She will just give you introduction for the troubleshooting of the Kjeltec. Thanks.
Thank you for the demonstrations. My name is Maria Wickman. I'm a market specialist in the lab segment in FOSS. And the next part will be about Kjeldahl troubleshooting. So when you get problems when running Kjeldahl, you need to locate where in the procedure you have the issues. Could it be in the application that is wrong, or in the different step, the digestion, distillation or titration? Could it be the homogeneity of the sample, or maybe volumes or concentrations of the reagent that you use? Or maybe is this a hardware issue? If you have issues with high blanks, when we talk about blanks, we mean empty tube blanks. We have two different blanks, the empty tube blank and the digested blank. And when we talk about high blanks, we mean blanks higher than 0.25 milliliter. They should be below that. And remember, because it's important, the last blank is used for the calculation of the results. If you have issues with low recovery, then you can do a recovery check. And for checking the distillation unit, you can use ammonium sulfate. To check the digester system, then you can use tryptophan or glycine, or you can use a reference material that is known samples with a known value to run together with your samples to see that the analysis is done in the right way. If you have a poor repeatability, then you can do a repeatability check to run at least 6 samples with a known value. You can also use ammonium sulfate or a digestion standard. The basic digestion procedure, that is to use 1 gram sample. The salt, to use 2 KJELTABs, that is a salt and a catalyst. Sulfuric acid, 12 milliliters. And the temperature in the digestion block is 420 degrees. And the boiling time is 60 minutes. In the KJELTAB you have salt and you have a catalyst, and this is used to speed up the reactions and speed up the analysis. The salt in the KJELTAB is a potassium sulfate, and that is to raise the boiling point of the acid. And the optimal acid salt rate is 12 milliliter acid and 7 gram salt. That's the ratio is 1.7. And higher temperature means faster digestion. We use 12 milliliter of the acid, and that is optimized to 12 milliliter. And some of the acid is consumed by the sample, and some acid is lost during the digestion step. If we have a sample with a high fat content, that means it consumes more acid. So maybe you need to increase the volume to 15 milliliter for this type of sample. The reagents used for the distillation and titration. You have deionized water for the steam generator and diluting of the sample. Cold tap water for the condenser. And the volume of the receiver solution is 25 to 30 milliliter. And for manual titration, we use 4% boric acid, and for auto titration, 1% boric acid. And the titration used should be standardized, and the concentration is depending on the nitrogen content in the sample. The sodium hydroxide should be 40%, and that is weight per volume. And it's important that it's not more than 40%. Then you can use ammonium sulfate for a recovery check, and the purity should be above 99.5%. Some rules of thumb for Kjeldahl analysis. The blank should be less than 0.2 milliliter. You should use 6 times the acid volume for water. You should use 4 times the acid volume for sodium hydroxide. And in the 250 milliliter tubes, the sum of the concentrated sulfuric acid, the sodium hydroxide, and the water used for dilution of the sample should not exceed 117 milliliter. You should, of course, never use broken or chipped tubes, and never use a higher concentration than 40% sodium hydroxide, and that is weight per volume. And you should, of course, always use good quality for the reagents and the chemicals. And you should maintain and keep the equipment clean. In the next slides, we will talk about issues you can have in a Kjeldahl analysis, like low results, poor repeatability, poor blank values, high results, low results on tryptophan, and high and low results on ammonium sulfate. But we will start with the sample preparation step, because this is actually the most important step in all type of analysis. If you have a bad sample preparation, then you will also have bad results. So the first thing to look into is the homogenization of the sample. Then you should also check that you have the right sample weight or volume for the sample type you use. If you have a liquid sample, then you should start with evaporation of the water, and that could be done by ramping of the digestion temperature. That means you can start with, for example, 200 degrees to evaporate all the water, and then continue with 420 degrees for the digestion steps. You can also use boiling rods if you have a foaming sample, but we do not recommend to use boiling beds or stones, especially not if you have a Kjeltec with a tube brain system. If we have low results, then we can look into the digestion step. And if we have foaming sample, the reason could be that we have a foaming sample. We will come back to that. Could also be that we have too low temperature in the digestion block. Could be that we have not enough acid for this sample type. Maybe it's high fat content, and then we will have a salt cake formation in the tube. We will come back to this too. Could be poor reflux of the acid. That means that you will have sample residue on the tube walls, and you will not have a fully digestion of the sample. Could also be too high exhaust rate, that you remove too much of the acid, or too short boiling time. If we have issues with foaming samples, that can be minimized by different actions here, but the reason could be that you have a high fat, high oil, or high carbohydrate content in the sample. But you can minimize this by reducing the sample size, for example. You can also use boiling rods, or you can use an anti-foaming agent. And here we have listed hydrogen peroxide, anti-foaming tablets, or you can use octanol. You can also let the sample stand in the reagents overnight. If you have a salt cake formation in the tube, That means that you have lost some acid during the digestion step, and you will have a supersaturated solution in the tube. This can be minimized by using the right amount of acid. For example, again, if you have a high fat sample, use more acid because the fat will consume some of the acid during the digestion. You should also control the aspiration rate during the digestion. If you have a salt cake formation after the digestion step, you can, if you use FOSS Kjeltec, then you can distill using the SAFTEY feature. That SAFTEY stands for steam addition for equilibration. Or you can add a small amount of water when the sample is cool enough to handle. Or you can reheat them in a digestion block to melt the cake in the tube. But we will come back to the safe mode. In FOSS Kjeltec, we have this safe feature. It stands for steam addition for equilibration. And it works like this. First, you add water to dilute the sample. And then you add steam. And this is to mix the acid and the water and to solve the cake in the tube. And then during the distillation, you add alkali. And this is to avoid heavy reactions in the tube. And you don't need to pre-dilute with water, and that will also make that you will save time. If you have low results, the reason could be in the distillation step that the distillate outlet tube is not inserted in the boric acid. That means that you will lose ammonium to the air. Could be that the distillation time is not long enough, or it can also be that the alkali addition is not sufficient. In the titration step, the reason could be that you don't have the right normality of the titrant, so please check in what you have added. Could also be that you have the wrong protein factor. Could also be the boric acid. It's not correctly adjusted. When you adjust the boric acid, you should have a low positive blank value in the range of 0.05 to 0.15 milliliter. If we have poor repeatability, then we can look in the digestion step and check if we have a foaming sample. Could be that we have insufficient acid-salt ratio if we are not using the KJELTABs. Could be uneven temperature in the digestion block. Could be exhaust rate malfunction due to uneven water pressure, or poor manual adjustment of the exhaust rates. The exhaust rate, when you remove the fume, you should have a high in the beginning and then lower after 50 minutes, and then should be high in the end again. So this is also important to check. Could be that the digestion time is not long enough. In the distillation step, when you have poor repeatability, it could be that you have poor fit between the tube and the tube adapter. So check the tube adapter. If it is deformed or worn out, then you need to replace it. Could be the distillation time, it's not long enough. Could be dirt in the splash head, that means you need to clean it. Can also be the dispensing of the alkali, it's not correct, that you have got air in the tubes. If you have changed the alkali tank, it could be that you get air in the tubes, and that could be a reason for poor repeatability. Poor repeatability and the titration step. Check the titration vessel so it's clean, or the receiver flask. If you have manual titration, the reason could be the different endpoint judgment by different operators, or it could be that there is air in the burette system. If we have high results, check the digestion tubes so they are clean. In the distillation step, could be carryover from previous insufficiently distilled sample. Maybe you have had too short distillation time for the previous analysis, and that can give you carryover in the next sample. Could be that the reagent blank is not subtracted, and could be that the splash head is not clean. And in the titration step, could be the wrong concentration of the titrant used, or that you have air in the burette system. If you have poor blank values, you should check the splash head again to see that you have a clean splash head. In the titration step, it could be the wrong adjustment of the receiver solution. And here you should adjust so you have a blank value on that should be in the range of 0.05 to 0.15 milliliter. You can do a recovery verification. All this information can be found in our application note, AN 300, but there are different ways to check your system. The first A is used to check the digestion system. The B is used to check the distillation and titration. And the last step is to check the whole procedure. If you have issues with high or low results during the quality control, when you use ammonium sulfate, you should check the purity of the ammonium sulfate. The purity should be in the be above 99.5%. You should also dry the ammonium sulfate before you weigh in. And you should check the concentration of the titrant used in this quality control. The quality control for the digestion and distillation procedure, when you use tryptophan, then you should check the procedure, that you have the right procedure for tryptophan. Also, you should also check that you have the right digestion time. For this quality control, you can also use glycine or acetanilide instead of tryptophan. This was actually my last slide. Thank you for listening. Now I will hand over to Bradley.
Hello, my name is Brad Buckman. I am the Field Service Manager for FOSS North America. I'll be going over our service structure, best way to reach service, field service engineer locations, and additional contact information. So our location, our FOSS North America headquarters is located in Eden Prairie, Minnesota. So this is our main headquarters in North America. This is where our call center, which is called OPE, One Point of Entry, resides. All of our offices, training rooms. We offer about 20 classes per year to our customers for FOSS instrumentation training. This is where our parts warehouse is. We have a repair shop for in-house repairs and QCs on new equipment. We also have an innovation lab where we have instruments on display for customer visits and demos. So our service team structure, we have 5 call center personnel, OPE. We also have 5 application specialists who do a lot of remote work on connectivity, calibrations, software upgrades, configurations, just to name a few. We also have 1 technical support person who is an extension of field service, and OPE who does just remote technical support. And we also have 30 field service engineers in the field. So what's the best way to reach service? The best way is again to call our FOSS call center, which is called OPE One Point of Entry, 952-974-9892, option 3 for service, or you can email support team at fossna.com. This is where you can start a service request. You can order parts or reagents. You can ask for a salesperson. It's basically just one call for anything you need from FOSS. So here's a quick map showing locations of field service team in the US and Canada. We have a quite, a knowledgeable group that range from experience on FOSS instrumentation, anywhere from 5 years to 25 plus years. And if there's any other issues that are kind of outside the box, not normal service, anything you would need to talk to me about, any kind of an escalation, an ongoing issue, anything like that, feel free to reach me through our call center, or you can email me at buckman@fossna.com. So now I'm going to turn it back over to Marcy for her sales introductions. Thanks.
Thanks, Brad. Hi, I am the Industry Sales Manager at FOSS North America for the laboratory segment. In addition to that, I support all segments with our chemical analysis products. That would include the Kjeltec, SOXTEC, FiberTech, DumaTech, as well as sample mills. If you have any questions about these products, you can reach me directly on my cell phone at 612-840-7522 or via email at mrussell@fossna.com. Otherwise, you are free to call our office at 952-974-9892. Extension 2 will bring you to our Inside Sales group. Thank you, and we can move on to the Q&A section now. Thanks. Hi, I want to thank everyone again for attending. We can now answer the questions that people sent in. Feel free to use the chat function to send in some questions. Let's see, the first one is, what is the concentration of the stock citric acid, which is diluted with the 25 milliliters of DI water? Carrie, do you want to answer that one?
Just a second, he is going to answer. Just have some technical issues.
Okay.
But perhaps you can just speak in.
Yes, Marcy, can you still repeat the question? Sorry.
Yeah, it was. The question is how much of the citric acid gets added to the diluted water? I'm sorry, the DI water.
Yeah, the concentration is 10% for the citric acid.
Okay. There's another question asking if we're going to share a recording, and we certainly will. We'll send that out tomorrow. And then, Carrie, here's another question for you. How many blank samples should be run for a dilution or a digestion step?
Okay, here we say you have the steps because you want to get very stable blank. And usually the first one you will get a little bit high, then you will get stable. And you want to make sure the blank is stable, then you have to run another 2, then you can see if it's stable. And that means that at least you need a run 3. And in our analysis, every time you want to make things perfect, so we will suggest you run 4 blanks in a row, especially when you have the auto-exemplar. So that means the first row in the tube rack.
All right, thank you. And then looks like there's just one more. If I only use a half a sample size, can I use half the reagents? Carrie?
If you have like half sample size, also I would suggest to just try the complete reagent, because that would be just safe for the digestion. You can just ensure the digestion is complete and get a good result, recovery. Or the other way is like if you think about you want to reduce the amount, you can look into another way like a micro digestion. That means you just reduce a little bit, but not the half. For example, the normal recommendation we recommend you use like a 12 milliliter for the digestion sulfuric acid. You can reduce like to 10 milliliter, then you choose another catalyst type.
Okay. And one more, Carrie, also for you. How do you clean the alkaline pump?
Yeah, the alkaline pump, you just there's a video for this one actually in the presentation. The way you do it is use the warm water, just rinse the alkaline pump. So you pump in the warm water and just wash out the particles inside.
Okay, thank you. And that's all the questions we have right now. But if you have any more, please feel free to send them to us, and I will send out the list of the questions with the answers as well. Any other questions we have here? Okay, well, thank you everyone for attending, and I hope you can make the next presentation next week.
Bye. Thank you. Bye-bye.
Bye-bye. Thanks.